plan for problem solving. It's a good section. Are all the worksheets, did they make it back to me? Hello?
Worksheets.
If there's extras, please bring them back to me.
I don't have no extras. Do you have extras?
There weren't any extras?
We didn't have no extras.
Oh,
We
man,
didn't have any extras.
Okay.
that's okay. Did not make that work.
I'm not trying to.
I'll just write it up here, the problems that I would like to do.
Flesh.
And I'll do them on my piece of paper and refer to a certain number. I need to make more than 25 next time. Okay, we're gonna talk about some basic concepts. I mean, you guys should have been doing this for a long time. We ought to be all right with the concept of what perimeter is. In layman's terms, I'm going to say it's the distance around a figure. I'm going to draw an oddly shaped figure.
Flesh.
The perimeter is simply, if Court was standing right here at this corner, he walked all the way around, always staying on the outside of the figure, the distance he walked is the perimeter. That's simple. It's that area around the outside. It's if you were to cut this up and lay it out, and it ought to create a distance, how far they walked, right? You're turning some corners here, but when it's all said and done, it's the distance around a figure. I probably should put the outside. Everybody understand that? So with that in mind, we ought to be able to find the perimeter. We have a formula in there for a perimeter of a rectangle. Capital P of a rectangle is equal to, well, a rectangle, what makes something a rectangle, and we'll go into a lot more detail with this, of course, when we get into quadrilaterals, which is what this is called because it's got four-sided figure. What actually makes something a rectangle, believe it or not, is that it has all right angles here. Okay? However, that's not something we're going to get into great detail now. What you guys need to realize is that when I put a mark like this, you know what this means? I'm saying this length and this length are the same. Length are the same, and the widths are the same in a rectangle always. So basically the perimeter would be length plus width plus length plus width, wouldn't it be? Walking all the way around. And we can simplify that into 2L plus 2W. Really the most important thing to remember about a rectangle is the opposite sides are congruent. Congruent means same size. And we'll get into more detail what congruency is here very, very soon because it's a very important thing in geometry. Same length. If this one was 5 inches, this one's what?
5 inches.
This one was 10 inches, what's this one?
10 inches.
Okay. I think we can do that, can we?
I can.
Well, that's concept of what perimeter is. Area, however, is a completely different thing. In essence, perimeter is one dimension.
Teachers and students, we are all clear. The lockdown drill is now over. We appreciate your patience. We have a big building, and not only that, we hit the other areas, ag building, gym, fine arts areas. It is long. It takes a while to check every classroom door that we have. So thank you very much for your patience. We appreciate it, and have a great remainder of the morning.
How many of you guys have ever heard about the area of a figure, or like your house? Square footage of your house. That's area. That's the amount of space. Okay? So if you have a rectangle, area is not odd. Not sure why we have that bell. Area is not talking about a distance. Area is what? If I was to, what would I do to demonstrate what area is? What would I color in? The inside. Area represents all of this, a measurement of all of that. It's a two-dimensional measurement. An example of a perimeter, back up here to perimeter, you could have a perimeter of 10 feet, let's say. That would be an example. An example of an area wouldn't be 10 feet, but it would be 10 square feet. And the reason for that is our formula for finding the area of a rectangle is length times width. LW. So the reason you have square units is because the length is measured in feet or something, correct? So you basically have feet times what? Which equals feet what? Hence why you have square units. And when you write your answers, it's important that you write them as square units. There's no such thing as having an area of 10 feet. That's impossible. Oh, I was almost right. No, it's 10 square feet. That's why I talk about square footage. What's up?
Like you said that on the area of it, the length times width.
Okay. Yeah, that's right. The length here times the width. Okay. And guys, one thing to realize too, if I turn this over this way, right? That might be the length, right? Then that would be the width. It's basically the two different sides in a rectangle multiplied together. Okay? So really what you define as the length and the width isn't that awful important. Okay? Now, the other one we're going to talk about, this was a what? Rectangle. This is our formula for a rectangle. Now we're going to talk about what is called a parallelogram. Now this may be something that's a little new to you. And just so you know, every rectangle is also a parallelogram. What makes something a parallelogram? Do you guys know what the word parallel means? What does it mean when two lines are parallel?
Lines that go on forever.
They never
without
intersect.
touching.
They never intersect. That's kind of one of those words, you know, you use in everyday life. Hey, running a parallel line to here, right? Running the same line just over here, right? So you're running the same direction. I know I've used the word parallel when I used to coach wideouts, talking about run parallel to the line of scrimmage. You know, squat, you know, stick your foot, run parallel to the line of scrimmage. That meant, you know, line of scrimmage is where we start, right? You to run to here, then be parallel to it, right? That means they never intersect. So parallel's a word that you guys should have, hopefully have dealt with sometime in your life, and you know, it's used a lot. What that means is that the opposite sides are parallel. And believe it or not, this is our sign. We use we use arrows to indicate that sides are parallel or lines are parallel. And we'll get into this also more in the future. We're kind of just introducing this to talk about area right now. We're not going to go into great detail about parallelograms right now. The only thing you need to know is they're just like rectangles. The opposite sides are what? Congruent. They're the same length. Now, but here's the big difference in the formula. Area, I'm going to put period, of a parallelogram is equal to base times height. in this case, this is your base, B. Okay? The one that can get a little bit confusing is the height. And I always use my wonderful drawing skills to try to demonstrate that. Most of you, if you haven't flown on a plane, you've heard about a plane and you've heard in a TV show or something about them saying, we're flying at 30,000 feet, right? Everybody's heard that. Well, here's a picture of my little airplane here. Isn't it beautiful? How do they know how high they're flying? How do they measure that?
Latitude.
It's the height, right? Well, how do they measure it though? I mean, think about it. Are they? Let's say this is the airport over here. A bunch of tall buildings. This is the airport. And you don't have to draw the picture of the plane. I'd much rather you probably listen. Remember, you can always watch it online. I have my own show online. It's my class. Now, all kidding aside, the point I'm making is, I mean, when they say they're flying at 30,000 feet, are they talking about this distance?
No.
From the airport there?
No.
Are they talking about this kind of angle? How would you guys, in your own words, describe how they measure that? How do they measure it?
From the ground.
From the
Straight
ground,
up.
but all of these are from the ground.
Straight up.
Straight down.
Down.
Very good. That's actually the word I was looking for. That's probably straight down. That's their altitude, isn't it? Now, if you look at the line that the ground makes, and you look at straight down, how do you think in geometry do you think we would define straight down? Court, what do you think? How would you define straight down? If this is a line making the ground, and this is a line straight down, what does it look like? Anything? Okay. Anybody else?
Straight down.
Straight down.
Yeah.
Ah, there's the word I'm looking for. And I expect you to know perpendicular, but what's an angle, the angle we're used to seeing? What is this called? A right angle. In other words, a 90-degree angle, like a box, making that. Because see, as this line goes out here, what happens to that angle? It gets bigger, doesn't it?
Yeah.
Or smaller, depending on which point of reference you got. So when we talk about altitude or height, we've basically got something that's the ground, and we'll call that the what?
Base.
And then we've got the height, which is measured straight down, or 90 degrees. So you kind of see what I'm saying about height, how we measure that? Of course, it's okay not to know the answer, nothing wrong with that. You're not like, got an F in class or anything, And I promise not to just pick on you because you're more outgoing than most. Don't worry, Dean will get his soon enough. Once again, I like to kid, but all kidding aside, back on the point, how am I going to do height here? That's what the H stands for. Isn't this basically the plane right here?
Yes.
And this would need to be measured what? Straight
Now.
down. Or on a,
90 degree.
right. That's how you have to do height. So this would be your height right here. I'm sure you've seen this concept before, but maybe it was never, But what you guys have also got to realize is I'm going to do my best to do this. I'm not the best drawer in the world, but I'm going to try to draw a picture of this same thing, but I'm going to flip it. So that's like my one that had the 2 arrows on it. Everybody see what I'm doing? Base and height is really dependent on your perspective. This may be the same trying to be at least. I know it obviously is, I think, a little bigger and not quite the same, but close. Is there another way I could draw a height now?
Yeah.
Wouldn't that be a height?
Yes.
But that'd be a different length than this. But here's the thing. To this height, there's a different what?
Base.
Because the ground is here now, isn't it? If I was to draw that over here, it'd be kind of like right there, wouldn't it? That height. You see the difference?
Yeah.
So they don't have to always make it where the ground's the bottom here. You know, they could turn it sideways on and mess with you. You should still get the exact same answer. Okay? Make sense? So we could call this height 1, base 1. Height 2, base what?
2.
Either way, you should get the same answer if they're the same area. Okay? It's just your perspective of which base you're talking about. The other thing I want to talk about is your plan for problem solving. Explore the problem, plan a solution, solve the problem, examine the solution. We'll get to that when we get to our last example from our workbook page. Okay? Guys, try to see if you can find the perimeter. What is the perimeter of number 1? See if you guys can figure that out. Huh?
24.
Number 1 is, let's see, it's up and down like this. The top is what? 3 what?
3 inches.
What's the side?
8 inches.
What's the perimeter? If
22.
it's 6 plus 16, 22.
Inches.
Use a capital P. Okay? What is the area?
24.
What do you do for area? Length times width. What's it's be 3 times what?
8.
When you do your problems, I know that you can do that in your head. I know that here you could go 3 plus 3 plus 8 plus 8. I understand that. But like I said, and on the sheet I gave you yesterday, Common Core is being able to explain what you're doing no matter how simple it is. And think about it. Is it really that hard to write that down? What did that take me? Writing 3P equals 3 plus 3 plus 8 plus 8 to prove to me that you did the problem took you how long? Let's time it. How long did that take me? 3 seconds maybe?
I was thinking 30.
Huh?
Yeah, maybe 3. If not 4.
Okay, we'll go with 3. Say I give you 30 problems. How many seconds did I add on to your assignment if it's that easy to show your work? 1.5 minutes.
90 seconds.
So the whining that I don't want to take that long and I don't want to do it, it's really not that valid. Okay? It truly isn't. And if it took you another 3 seconds to write the problem, let's say we got all the way up to 5 seconds. In fact, I'll be even mean and let's go to 10 seconds to write the problem. And for 30 problems, that's 300 seconds. How many minutes is that? 5 minutes? 6 times 5 is?
Yep.
Yeah. I had 5 minutes to your assignment. And then to show your work, it took you 5 seconds. I added a whole 7.5 minutes to your assignment to explain to me and prove to me that you're doing what you're doing. Guys, if we did 2 assignments a week, I'm asking for 15 minutes. Is that too much? No. Are there times where that number could be 30 minutes a week? Yeah. Maybe you have to write a little more. It takes a little longer. You see the point I'm making?
Yes.
It doesn't take as much. If you know what you're doing, it doesn't take as much time as you think. And if you don't know what you're doing, you need to ask for help. being able to show what you're doing shows me that you understand the concept of what perimeter is. Hey, would it have been okay for somebody to write 2 times 3 plus 2 times 8 here? That'd have been fine. Show me how you got what you got. It doesn't have to, don't think that there's a right and a wrong answer. The way you show it may be a little different than how another person shows it. At some point, it will get to be a wrong answer. That's not enough or something like that, but come and ask. See the point I'm making? Prove to me you're doing the work, that you're showing your steps. A lot of the reason I'm doing that too is because we're in an inclusion class right now. We're not going as fast as the others. We probably shouldn't be doing a bunch of stuff in our head, should we? I'm hoping that wasn't on.
No.
Okay, now that I've ranted and raved about that. Area, 3 times 8. Now, I put it in here without the units, because that can get confusing. Only do that if you can write the answer correctly. The answer is 24 what?
Into
Square inches. Have to write that. You guys see any problems on there you couldn't do? Let me see that sheet one more time.
15.
On number 15, what is your base?
3.2.
No.
On number 15, you've got this picture. And like I said, I've also told you guys your pictures don't have to be works of art. They just got to get the point across. Sometimes, like I said, a big part of geometry is being able to pick out of a problem what you need. You'll find that there'll be a lot of times where they give you more than what you need. What did they give you here that you don't need to find the area?
10.2.
They gave you this. Because why is that not needed? Because I don't have the base that goes with that, or the height that goes with that base. What did I tell you about parallelograms? The opposite sides are what?
Equal.
So if this is 3.2 inches, what is this?
3.2 inches.
So area's base, which is what? 3.2 times height, which is what? What do you get when you put that into your calculator?
30.08.
Dang. 30.8.
08 or 8?
08.
Okay. That's your answer. Okay? What if they ask for perimeter? And they may have. What is the perimeter here? Now you need the 10.2, don't you? How would you find the perimeter? Tell me. Prove to me that you know how to do it. Just quickly write it. 10.2 plus what?
10.2
3.2.
plus 3.2 and 3.2. But no.
Like I said, no way that took you that long. What is all that added together?
Numbers.
Using your trusty calculator. Huh? 26.8 inches, right?
Yes.
Now, you need to get your notes back out. We have one more example to do. And I need you to try to do as good a job as you can to copy this down how I have it up here.
change.
40.
Yes.
Okay, we're gonna say this is a house. Let's make this line up with this right here. Find the perimeter and square footage. What is square footage? The area. On some of these problems like this is the one time that anything that you assume is a right angle probably is. I'm pretty sure I've given you enough information to find everything you need. When things look like they're directly across from each other, we're going to assume they are. Okay? Like for instance here. Okay, I know this side, I'm good there. I know this is 20 here, okay? I need to find every side, don't I?
Yep.
Would everyone agree with that? That's 8, that's 20, that's 10. I don't know that one. So that's the first one that we don't know. Can anybody give me a hint, an idea how we think we could find this side right here?
Take 100 minus 40,
Why would that be? Why are we doing that?
because 100 and...
Here to here is 100, correct?
Yeah.
So, and we know this is 20 and this is 20.
100 minus.
So this is 40 of the what?
100,
So what's the only thing left for it to be?
60 feet.
Everyone agree? Okay. What's this side then? Anybody?
10.
10 feet.
10.
This is 20. What's this one?
10. 100.
What's this one? 100 foot. Now, how in the world am I going to find this one?
20 plus 8.
No, 20 plus...
Where would 20 plus 80 get you to?
90.
Wouldn't that get you to right here? Everybody look up here. I'll tell everybody, don't worry about writing down right now. I'll let you write this down after we're done. I'd rather you watch than write it down. This from here to here, that's 20, right? Then from here to here would be 80, right? But what's here to here?
Subtract 10.
10.
That's 10.
So 20.
So it'd be 20 plus 80 minus what?
10.
Minus
Would make it
70. 90.
Everybody see that? So, first part, part A, finding the perimeter. Remember guys, I'll let you write it down after we're done. Pay attention. How am I going to find the perimeter? Can anybody tell me? Where do you want to start? Right here? I mean, is there a formula for this? No, actually there's not. This is just walk around it and write down how far you go each time. Be 80. You walk from here to here. So that's what?
80.
80. Then when I walk to here, that's what? So plus what? Then I walk to here. So plus what? Then I walk to here.
60. Another 10.
Then I walk down to here. Plus 10.
Another 20.
Then plus 20. Then what's another next part?
Another 10.
Another 10. It's tedious, but, and then from here to here is another what?
100.
I'll come down to here, plus what?
100 minus 10.
No. Here to here. 90. Plus, what's here to here?
100.
100. Plus,
20.
what's here?
20.
And then here to here. What do you get when you add all that up together?
620.
Is that what everybody else got?
I have messed up.
Now, here's the kicker. And you could have different ways to do this. How in the world am I going to find the area? D, do we have a formula for something that looks like a dog with a big square head with 2 sets of legs?
No.
I was trying to figure something I could use to describe that. We don't have a formula for that, do we?
No.
So break it, this is part of the problem solving. Break it up into things you do have a formula for. Aren't there a bunch of rectangles here? So couldn't I break that up?
Yep.
That?
Yep.
And then I can either break it here or I can break it here. Which place you want to break it?
There.
Down?
Yeah, down.
Break it there. What we usually do is we would call this in Roman numerals region 1. This is how you'll see it in math, region 2, region 3, and region 4. You basically need to find the area of region 1, add it to the area of region what?
2.
Plus the area of region what?
3.
Plus the area of region what?
4.
Each time, area of region 1, it's what? 10 times what?
10.
Don't put your books up. Stop. What's the area region? Oh, I'm sorry, that wasn't region 1. Region 1 is what? 100 times what?
80.
100 times 80 plus region 2,
100 times 100.
100 times
100.
90.
90 plus region 3.
10 times 20.
Way too much chatter during notes. Stop putting your stuff up. Region 4
10
times what?
20.
No one leaves until I'm done. Now, what do I get here?
100.
800 plus what?
900.
Or 9, right?
Yeah.
That's 8,000. 9,000 plus what? 200 plus what?
200.
You're not leaving yet. That's 17,400 square foot house.
They own them.
That's a mansion. That's big. Probably a school, an elementary school somewhere. Your assignment is online. Okay?
I'm gonna log on as soon as I get out of here.
I will take a picture of this with my phone so I can put it up here for you guys to write down tomorrow, since we ran out of time.